All right, we're back. Welcome back to the Pacific Transformer podcast. With me again, as always, I have Justin, the CEO of Pacific Transformer.
What's going on, Marty? How you doing?
I'm doing well. All right, today's another fun one. We're in our industry series. So we are working down through the different industries that Pacific Transformer is well known for. Done a bunch between aerospace, medical, and a bunch of others. Now we've finally landed on another fun one, automotive and recreational vehicle. So I mean, because we're in a lot of industries, we're gonna be at this for a few more months at least in terms of getting through the industries, which will be fun. But
Yes,
it'll give you
sir.
a nice spread at the end. But automotive, exciting stuff. When I did my homework, and just being around the company for a long time now, the amount of work that you guys have done, again, is in automotive is equally impressive. I mean, you think like between the stuff on Mars and the stuff, and on stages throughout the world, that's super fun too. But yeah, equally as much in automotive. I mean, some of the biggest names that everyone will recognize, you name it, you guys have probably touched it. So, um, let's get into it. There's
Yep.
automotive is a big swath. We're talking from, you know, consumer vehicles
Yep.
to vehicles that are meant to help move around transport vehicles to
Yep.
municipal transportation. There's a big swath of automotive that you guys do work in. But before we get into that, I really want to wind back the clock to some of the earliest stuff that you guys have done in automotive to kind of set the stage. So I'm going to turn it over to you for that.
Yeah, no, you hit it on the head, and it's kind of funny because when the layperson thinks about automotive, it's combustible engines, just like that's it, right? Like a car on the road, and that's all automotive is. It's a car.
Yeah.
We look at it a little bit differently, and now electric vehicles are all the rage, right? And it's starting to be a lot more commonplace, and I can't drop off my kid without coming into maybe a dozen Teslas looking to turn into the into the driveway of the elementary school, right? But for a long time, we were getting involved in the automotive space, not necessarily from the onboard stuff, but a lot of the tangential parts that are supporting automotive. So you touched on a few of them already. We don't look at automotive just as a car on the road. Right.
Mm.
We look at automotive as anything with wheels that needs to move from one place to another. And so again, that could be something as simple as the cart that's moving your luggage from the baggage claim to the plane, right?
Sure. Yeah.
And how those are charged. It's some RVs, right? And making sure that the power that you're hooking up to at an RV park is conditioned appropriately, so your AC doesn't get blown out. It could be something as crazy as the Mars rover. You mentioned it
Yeah.
before, right? But for us, that's kind of automotive. It has something to do with the way that things are moving from one place to another. So we've always been conditioned to think about it from that aspect and to make sure that we're approaching each project not necessarily with from the viewpoint of just one kind of secular approach, but really looking at it and trying to use our experience in all different industries in order to provide the best product to our client. So sure, some of the early stuff was still like we're talking about and what's popular nowadays, like an electric vehicle. We were involved at the very, very beginning stages of the old Chevy Volt more than 20 years ago. We were brought in at the prototype and concept stage of that vehicle, in doing a lot of really interesting work there. But even before then, we were doing a lot of the electric vehicle charging, not necessarily for EVs like we see today, but again, just the little carts that are going back and forth to cars or to planes rather, and for other kind of sea vessels or other instances like that need charging. So that's really kind of where we got our start. But then getting into the more conventional electric vehicles, we had already made our name in that industry, and so
Yeah.
it was a very easy transition for us also to get brought onto those more commercially viable projects.
Yeah. So we were talking earlier, and I remember talking with Pat about this, and it goes back to the history of the company, which is really fun in and of itself. It's the stereotypical started in the garage, grandma's station wagon, the whole bit. But winding back the clock to there is a through line in automotive going back to the very first product that you guys ever delivered as a company, which was charging for yachts and big and vessels, if I'm
Yeah.
not mistaken.
Yeah, yeah. So our very first customer ever in existence. So back in 1981, it was for their system was more or less like power conditioning for sea vessels that came up and then needed to be charged while they were docked, right?
Yeah,
And so that's going all the way back to 1981. And if you think about it, not much has changed, right? You know, you pull the Tesla into the driveway and you plug it in, and it's charging and doing a lot of the same things that we were doing back in 1981. So it's only like that natural evolution of keeping that core competency of knowing kind of what we were doing back then, and then just building on that and improving over 4 decades, almost 45 years now.
that's
That
wild.
Yeah, it really is, and it's just those. It's not just the competency of knowing the engineering side of things, but it's also the manufacturing of it and having, because with automotive, you can't have any failures whatsoever.
Mm,
I mean, it's even a higher threshold than most of our stuff. And so it's not only knowing how to design it, it's knowing how to manufacture it. But then over those 45 years, also building up those relationships with the companies and the engineers and the procurement teams of these different groups who go on to work at the Teslas or the Rivians or wherever it might be, right?
yeah,
So it's something where we've just been, I'm not going to say, in the shadows, but we've been like that integral part of that infrastructure for so long, and now we're just finding new applications for our core competency.
yeah. It's funny because you first of all, the thought of the Chevy Volt coming out 20 years ago almost pains me because I remember it like all too well. And like, and then as my hair's falling out, I realize, oh yeah, I guess it has been that long, hasn't it?
Yeah.
But I remember predating that. We would go to which is going on right now, the Orange County Auto Show every year, right? My dad and my grandpa and my uncle and I would all go. It was just kind of just a fun thing that we all did each year.
Sure.
But I remember what was the little the car the thing that the documentary was based on, who killed the electric car? It was like the Saturn EV1. That's what it was.
Yeah, yeah, yeah,
This
yeah.
this
Yep.
little tiny car, right?
Mhm.
That they didn't sell. They only leased them, and then people really liked them, and then they ended up crushing all of them, and there was this big controversy around it. All that fun stuff.
Yeah.
And that was probably the mid late 90s, right around
Yeah.
that era. It's funny, then it kind of came back in, right, where there was like I'm obviously Tesla and all these other um manufacturers had a say in that, but and then obviously the advent of the hybrid vehicle, right?
Sure.
With I mean, look at the Prius, just blew everyone's mind. It like came out of nowhere.
Yeah.
And then you have General Motors getting into the game, seeing the success of the Prius,
Yeah.
and their response to it
Right.
was the Volt, right? Um, which you guys were an OEM supplier for, and a strategic what would you call it, an engineering partner
Yeah.
for that. Do
Yeah,
you
yeah,
want
yeah.
to speak to that? Because that in and of itself seems like that's new area for them. I mean, relatively in terms of hybrid, and you guys are brought in as a an expert in that field. Talk to me about that. How did you do you remember, like, how did it come about? Some of the parts that you guys were entrenched in, and is that atypical for you guys, or is that pretty commonplace for you guys to get brought in on some of these things to be
Yeah.
that arm in terms of that engineering prowess in that particular area of expertise?
It's funny that you mention it because I always like to say, like, sometimes a fish doesn't know he's wet, right? Like you're kind of going through and you're doing your day to day, and we get approached by maybe a specific engineering group or a consultant.
Mm,
Oftentimes, it doesn't have the General Motors name at the end of it or anything along those lines, but it's a maybe an outsourced engineering consultant, and they're saying, "Hey, we're working on this project, and it's a kind of a little shrouded in mystery, and it's a concept car or whatever it might be, and here's what we're looking to do. We're trying to make this switching power supply, but it has to be able to withstand all this inrush current or very, a ton of thermal cycling, and so you start peeling back the layers and you start understanding a little bit more, and then you start getting the overarching sense of pressure, and it's becoming a really important project, and you get the sense from the team you're working with. And at the same time, it's kind of I want to say we just kind of come in day to day and do our jobs, though, right? It's like I
uh,
don't want to say it's something that we held as a high pedestal. It's like, oh man, this is going to be it. This is the future. This is what we're going to be working on, and it's going to be revolutionary, because
yeah,
we're being brought in for a component, right? Now, the interesting part is, in order to do our jobs well for that component, we do have to understand the system. And so that's where we start really getting intrigued and learning more about kind of how everything fits together in order for us to do our job as well as we can. So it is interesting how we do start to uncover some of the interesting, and oh wow, this is kind of revolutionary. This is something that hasn't been done before. And it doesn't change how we approach what we do. We still have our marching orders. We know what we have to do in order to fit, this huge amount of power in this tiny little space and be able to
yeah.
keep it cool. But at the same time, we're coming in and punching the clock every day, and just trying to do the best that we can do and provide that quality magnetic to our customer.
Yeah. Are there times where you guys, I mean, to your point, it's a little bit shrouded in mystery. You just get specs and you're just asked to provide a part, to engineer something. You got the specs, provide it,
Yeah.
and then it comes back and you realize it's something that's pretty extraordinary. I mean, there's a lot of things that you guys have done where it's like, oh, that's super cool. The most extreme would be like the Mars rover. I mean, there's
Sure.
your parts that you guys designed, that you guys tested, that were wound in your factory, that
Yeah.
are that by your people in your hands, and that thing is now on Mars. Like
Yeah.
literally right now as we speak. I mean, that is kind of that's an odd realization, but you might not. I mean, you might not even
At the
known
time.
it was there at the time. You're just like, here's the company, they do work in aerospace and they need X, or this is the consultant, they're a design company, and they are supplying said part for the assembly. So is it often that you guys, it's way after the fact? Hey, by the way, that thing was for this really cool, like that was for the
Yeah.
James Webb Space Telescope, and you guys are like, whoa, that's pretty awesome.
It is. It's funny because, and I'll harken back to our previous podcast, right? When we were talking about either the medical, definitely like aerospace and defense. Like,
Yeah.
you don't get a lot of answers to your questions, but all of a sudden after the fact, you start to get little, kind of, hey, thanks. By the way, did you see the news clip? We appreciate you guys' work, or those types of things.
Oh, that's interesting.
Or like the or even just something that's is as nonchalant as like the audio transformers that we'll make, some of the FedEx envelope that we receive a year after working on a transformer, and it has nothing but Guitar World magazine with that says the best amp in the world, with a post-it note saying we couldn't have done it without you. It's like
Yeah.
just those little tiny things. Absolutely, right? You go back and you look at it and you're like, "Oh, that was really cool." Right?
Yeah.
And it kind of gives you that internal pat on the back,
Oh, there's a
for
sense of
whatever
pride.
reason.
There has to
It is.
be. I mean, how
It
cool is
is.
that? You know what I mean?
Yeah. And then on the flip side, like, it is kind of funny though, because those are the success stories, right? But I can't tell you how many times we have people who are coming in with some brilliant idea, and we do all the prototyping, and then we never hear from them ever again. Never again. They
Yeah,
fall flat, right? And it's this amazing idea and all this, promises and backed by private equity, and it's going to be the next, greatest thing since sliced bread, and then all of a sudden they go bankrupt or it falls flat on its face, and it's just the nature of our business because
yeah,
we have decided as a company, in order to be the type of partner who's going to be in a true partnership with your team in developing that prototype, using our engineering team here in order to develop that first article, that concept, with the unspoken agreement that after it succeeds and we go into production, we're also going to be the ones who are manufacturing that component for you long term, right?
yeah,
And because we have set ourselves up with that business model, we attract all sorts of types of companies and
yeah,
consultants and individuals who have these great ideas, but then they end up not going anywhere. So every now and then, when we do get
yeah,
that FedEx envelope, that little pat on the back, it's nice, right? Because you see these success stories. But at the end of the day, the success stories actually come in the form of POs, purchase orders for,
sure,
I need 1,000 of those units now, or
yeah,
10,000 of those units. That's where that's the real pat on the back.
yeah, yeah, absolutely. Well, let's we talked a little bit about your work as like a strategic partner for the Chevy Volt and some of the early GM
Yeah,
vehicle lineups. Let's expand into that a
sure.
little bit, and then kind of work through some of the engineering challenges. But let's first like unpack some of the hallmarks, right? Um, Everyone knows the name Tesla. I mean,
Sure.
they're synonymous with electric vehicles. And then let's get into some of the non-traditional stuff. Like we talked a little bit about the airports,
Yeah.
vehicles and things like that, charging infrastructure. It's all kind of related. So let's start with Tesla. What some of the stuff that you guys did for them, I guess, early on in current day.
Sure. Yeah, they approached us. Yeah, it was probably a decade ago now. They knew that we were heavy into the EV charging already, and they knew right off the bat that if they were going to be successful in selling their cars commercially, they had to reach a tipping point. And in
Yeah,
order to do so, they needed to make sure that the charging infrastructure was that was the number one fear for anybody who would be buying an electric car, was they run out of juice and they'd be stuck in the middle of the desert or something like
yeah,
that, right? And so for them, it was kind of a horse before the cart thing. They needed to make sure that they had just as many charging stations as there were gas stations. If for anything else, it was an aesthetic thing for them, right?
yeah,
And so they approached us early on and needed to make sure that they were able to come up with a specific type of transformer, specific type of magnetic that would be able to withstand a huge amount of inrush current that would allow for the charging of their cars to be done in a very brief period of time, something that had never been done before. And so they
I
worked.
don't think people could really appreciate that for a moment because you go to the Tesla Supercharger and you just plug it in and you're like, that was great. Like you don't think about it. But if you wind back the clock to 10 plus years ago, and not using the Supercharger network, you're down to about a 240 at 30 amps.
Yep.
And at that time, you're talking cars were about 100 miles was
Mhm.
like was the standard. And even at 100 miles, 240, 30 amps, depending on what charger you had on board, that's 4 hours still at the fastest that they had to offer. Now there was two other ones, which was DC fast charging and Chatamo, that never really took off because they had these competing standards. And the best part is with Tesla's Supercharger is they had the foresight to call it the North American like standard.
Yeah. 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 It was right off the bat.
Yeah, yeah. That they just what is it? NACS or something like that.
Yeah.
Like that's pretty bold, right?
Yeah. This is the
And
standard from now on.
yeah, yeah, they just claimed it. This is it,
Yeah.
which is funny in and of itself. And not only and so to have a system that was normalize the connector
Mhm.
and you didn't have to fuss with. And I don't think the other thing that people realize is that if you're not in the automotive, just the ability that you didn't have to fuss with apps or like I think the industry in it of itself went through this thing where it's like, well, we're gonna make this so easy. You just go on your app and you unlock it and all this stuff, and it became a nightmare. Where Tesla just said, you just plug it in,
Just
and
plug in
we
and
know,
go.
and it'll communicate to your car. It'll know what to do. Just
Yeah.
plug it in,
Yeah.
unplug it when you're done. Goodbye. We'll charge,
That's it.
and then we will whatever card you have on file.
Literally easier than a gas station.
it is. That was the only one at the time that was literally easier than a gas station, and that's still kind of true to this day.
It is.
To be honest,
And that's what I was going to say. You're talking, 5, 10 years ago, as far as setting that example, but I will give you like a straight up, another example. Like if you go to, like a charge point or something like that and go to charge your electric car, you're getting like how many miles in an hour? Like 8,
it,
10 or
it's like
something?
yeah, you're at most you're pulling about 25 when it's low.
80,
It's
right?
yeah,
How many miles do you get in an hour of a Tesla Supercharger? You're getting the full 220 or whatever. You know what I mean? Like it's a
yeah,
massive, massive difference. And so what they immediately recognized that if they were going to not just create this infrastructure to be able to sell their cars, remember the
yeah,
whole idea is to sell the cars. So they had to create this infrastructure, but then they had to not just replicate the model of gas stations, but they had to almost like make a better model than gas stations, something that you didn't even have to like go and tap your card. You don't have to download an app. You
yeah,
don't have to do anything. They're like, you don't have to smell gasoline and have a few drips come out onto the pavement when you're putting back the nozzle. Like
yeah,
none of that happens, right? And so in order to do that though, the whole entire um supercharger is dependent on a 2 kVA transformer. Like
mm,
that the entire guts of that system is completely dependent on a 2 kVA transformer. And so they worked with our team for months and months and months in order to come up with this final solution that ended up being just the absolute best in class as far as charging stations go, and you can see the result of it, and it was really one of the main reasons why Tesla, is now the name in electric vehicles because of their charging stations. So,
for sure. The
um,
foresight there was incredible if you think about it. Like oh, we build cars, not charging stations. They're like, no, we have to build charging stations to sell cars. That is a scale of that is hard to comprehend, honestly.
And it got
That
to
foresight.
the interesting thing, Marty, and this is more like is interesting given the current context of our geopolitical like environment.
Yeah,
We were manufacturing those domestically, those every single one of those 2 kVA transformers, and Tesla was manufacturing the superchargers as fast as they could, and they had
yeah,
two main manufacturing sites, one in Buffalo, one in Shanghai. Um, and they literally wanted us to manufacture everything domestically and ship it, obviously, to Buffalo, New York, but also to export it to China. So it was like
hmm.
one of the only things that was exported to China as opposed to being imported from China.
Yeah.
And we told them, multiple times, like, hey, from a logistics side of things, like we can, manufacture this in our facility in China and then drop ship it to Shanghai. And they're like, no, 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 absolutely not. We want to make sure to keep it there, stateside, get it done, export it. We'll take care of the rest. We said, okay, no problem. So we just
That's an interesting thought, actually. Especially automotive is so specific, like when you're talking about that scale and you're talking about cents on the difference between like cents and like a switch. Like, oh, this is only a few pennies more. But on that scale, that's like you just approved $100,000. You know what I mean? Like if you're talking that scale,
Yeah.
it's interesting though that I think that speaks to probably the difficulty and to nail specifically the load and reliability. I
I
have to
think
imagine because you go to those
100%.
superchargers, they are going all the time. They rarely are broken,
Yeah.
and when they are, they're fixed pretty darn quick. But even so, they're running 24 hours a day, pretty much. I mean, you it's hard to find a station that I guarantee that most of those things are taken up. It has to be 80% of the day.
Well,
It's a car's plugged into them.
and actually you're half right but half wrong. So they
Ooh,
are like um like constant usage is a stressor, right? But
yes.
what's even more is when you have a low battery and you plug in, there's a huge amount of inrush current. And so it's the volatility that puts the most stress on the actual transformer itself. And so it's the constant volatility that makes the reliability of the transformer paramount more than anything else. So it's that spikes in that
Mm,
inrush current, just boom, 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 as opposed to just if it was constant level. That's more like a pad mounted transformer that's sitting there and just transmitting, 34,500 volts down to 12,000 volts. That's always being used. And so yes, it has to be reliable. It has to be a tank, but it doesn't have the same sort of stress that something where it's plugged in, plugged out, plugged in, plugged out, plugged in. So
mm.
that's kind of where that extra stress comes from, is that inrush current.
So that's a perfect segue on some of the frame of mind in terms of engineering. Like, I think automotive, the first thing it's so easy. Like the first thing I think of when I think of automotive is obviously a car for obvious reasons. And then
Right.
when you think of car, I think of a couple things. Shock and vibration
Yeah.
and extreme temperatures.
Yeah.
Both in cold environments and hot environments, particularly hot environments. I mean,
Yeah.
we live in Southern California. I mean, these things get
Sure.
everything gets baked in there. Um, those are the two things I immediately think of, and it almost is a modern marvel that these vehicles are take the least reliable vehicle that's made, and you still think about it how reliable it actually is.
Yeah.
Like, if you really think about it for a moment, it's like, oh wow, those things really don't fail. Like I've gone through more. I have literally gone through more washing machines in the past 10 years than I have in terms of like reliability on my car, and yet that is,
Uh,
you know what I mean? Like if you think
right.
about it, it really is amazing considering the strain that is actually put on these
Sure.
vehicles. So can you talk a little bit about some of the philosophies and some of the space constraints too? I mean, there's a lot of different constraints that you guys have to think about.
Sure.
And when people present you with a specification, I assume they provide temperature ranges, shock vibration, all the fun stuff. Do you want to speak a little to that?
Oh, sure. Yeah, and I think the dependability of the automotive sector is based in two things. One of it is the test that you have to perform, and you were talking about some of them. So the thermal cycling, like absolutely the vibration, shock and vibration test. Thermal cycling. Think about it. You have to have something that is an electric vehicle is able to be rolling through Death Valley, where like ambient temp is 150 degrees, something like that, and have that same car be rolling around Norway or like Siberia at negative 65 degrees. Like, what kind of, the only thing that we've done that has that type of polarization is the stuff that we put on satellites, where it's,
Yes.
behind the sun, or, in front of the sun and then behind the moon, and
Yeah.
having that type of thermal cycling. So we're used to doing it, but absolutely to be able to have that along with all the other stressors is quite the feat. Um,
What goes into, like, making a transformer robust? I mean, like, I see, there's the coil, like, the route, like, what makes it, is it the way it's mounted? Like, what are some of the considerations when you think about, like, these things have to be robust? Like, what are some of the top considerations?
wow, that we're dipping into if I told you I'd have to kill you
Ah, I see.
territory.
I see.
But
Yeah, 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 yeah.
no, I think so. A lot of it has to do with the proper manufacturing, instructions to make sure that it's not just done the first time, but it's done repeatable. You every single time it's correct. So a lot of that has to do with the proper installation, the over designing the components
Mm,
on the forefront, right? So in order to make sure that you aren't just designing it in order to provide the like the 2 kVA of power in those superchargers. You don't design it to be able to provide 2,000 uh you know watts. You're designing that to be able to provide 3,000 watts,
yeah,
but you derate it at 2 kVA.
right.
So and those are some of the things that you do in order to make sure that it's able to withstand that extra pressure. That
Yeah,
and like insulation, like using the good ingredients. It's like what's the difference between, McDonald's and the French Laundry, right?
yeah,
Ingredients.
yeah.
I mean, like you just have really top-notch ingredients, and so using not cutting corners, using Nomex, using extremely high grade wire, good lamination, and making sure that you're just taking all the proper precautions.
Got it.
So yeah, that's basically what it boils down to.
Yeah, which is, if there's one thing I've learned too in just doing this is, there's a give and take, and I think a lot of customers are aware of the give and take. Um, when you make something robust, I think weight. Right?
Mhm.
You
Yep.
need to build something for a certain reliability. You need to over engineer it, but that comes at more wines. You're to not get stressed, which is
Yep.
the give and take is weight. So but then there's counterweights in terms of, like, well, we might be able to use different materials, but that might have a push and a pull. So that's really where I guess the engineering of aspect comes,
Oh,
and really understanding what it's going in, so you can help them decide on a path
yeah.
for that reliability.
Yeah, and that's where that collaborative process comes in,
Right.
right? Because you lay all the cards out on the table and you say, okay, listen, I can, you know, I'm not, cutting back on the quality. Like that's a non-negotiable. So
Yeah.
if, this is how we get the project done. Now, I can do this by creating something that is larger and that's going to get the job done. But then it doesn't meet your weight, specs. It's
Yeah.
it's 5 pounds too heavy. So let's shrink it, and the way that we shrink it is by using, Litz wire or, nickel lamination or whatever, M2 as opposed to M19. And so we can reduce the size of it. So now it hits your weight and the quality, but your price goes up because we're
Yeah.
using more expensive materials. So it's being completely transparent and saying like, "Hey, this is what we have to work with. You pull the levers. You let me know where you want to push, where you want to pull." And they appreciate that from the onset, because if we're just sitting here behind the curtain saying, "And here's your quote," and that's it, and then they have to push back and like demand certain specs, not knowing the reasoning behind everything,
Yeah.
right? So transparency for us has always been just a mainstay and the foundation of our communication.
Yeah. Yeah, that makes sense. I mean, it makes perfect sense. Let's jump into some of the certifications that are, before we get into, like, fuel, like, there's a couple really cool things I want to talk about in terms of, like, fuel cell vehicles and some of the other things that, and some of the RV stuff that it's a little bit more, a little further out. I think that's kind of exciting too. Let's talk about, like, some of the certifications that people would want to see and kind of hear for. I mean, you have ISO 9001 and, like, a few other things like that. I'm sure UL, CE, CSA. It's like, what are some, when you talk to a manufacturer of any sort of automotive, what are some of the compliance requirements that they're typically looking for?
Yeah, so a lot of it is obviously you have the standards, like the UL, CSA, ETL. You already hit all
Yeah,
you have to be ISO 9001.
yeah.
It helps that we're AS 9100, so we already hold ourselves to a higher standard than most everybody. So you kind of already get that benefit of the doubt
Mm.
when you're working with defense companies and aerospace companies. The automotive kind of use that as a proxy to say, okay, these guys know what they're talking about. They have the proper procedures and departments in place in order to make sure that they're pumping out quality products,
So
right?
you think your take is oh, these guys have an ITAR registration with the US government or whatever the case is. They're probably good, and like that's a good indicator that they're more than capable of doing our project. Like having those at your disposal, like, hey, we've got this is a good
Yeah.
is a good indicator of they can handle my project. That makes total sense.
Yeah, it is. Now, I will say that the automotive world is a little bit different on how they qualify new products. So that's the second half of the equation is like uh, during the like new prototyping and new like vendor introduction process when we're taking over a portfolio from, for a new customer. Um, the things that we do for an automotive customer are different than what we do for a normal commercial customer. So we're going through and doing like a PPAP process where we're formally submitting like a breakdown report of like the entire transformer itself, and we're doing a full write up on the construction layout of the testing. We're doing overload testing, just all the additional requirements that need to happen in order to make sure that it passes muster on their end, right? So
Yeah.
there are some like common practices within the automotive industry that we are accustomed to when internally qualifying parts. And so that burden's put on us in order to make sure that we become accustomed to filling out that reporting, submitting it to our customer, and then they sign off on it. So it's not even like a third party, but it's just a way of doing business within the automotive world that you have to know how to do if you want to make sure to get into that industry.
Oh, interesting. Yeah,
Yeah.
I would have never thought. Okay, let's wrap by talking a little bit about some of the automotive that's a little further away from the car in the driveway. We talked a little bit about airport. We didn't
Yeah.
talk about some of our what's the word I'm looking for? Like mass transit.
Yeah. Yeah.
Let's fuel cell. There's a lot here. Let's kind of rapid fire at some of the stuff that you guys have been involved in terms of the automotive sector, just to give people a bigger view of what automotive can mean, even though we kind of briefly
Yeah.
talked about it in the beginning.
Well, I think what's interesting is yeah, we look at electric vehicles as our commercial vehicles, in our
Yeah,
driveway every day.
yeah.
But there's been electric vehicles for decades, that are constantly in use. And so again, it's the stuff that's powering up planes while they're on the tarmac, moving stuff from point A to point B. Those need to be charged,
Yeah.
and those need to be run from one place to another. So we do a ton of business with companies like Aviation Ground Equipment and these other guys who don't have the name brand as a Tesla or the Chevy or GM or
Yeah.
Harley-Davidson. Even we did a bunch of work with them.
Oh yeah,
Um,
I forgot the so
yeah,
for let- I want to actually plug something a little bit because there's a documentary on Apple. I think it's Long Way Up with Ewan McGregor, and he has
okay,
a buddy named his buddy Charlie, okay? And
yeah,
every 5-10 years they go on these massive motorcycle trips,
yeah,
right? Which is super fun. It's like it's a season. I think it's like 8 episodes each, and Apple took it over. And when Apple took it over, the first one that they did was a series called Long Way Up. Okay,
okay,
and then they rode from Patagonia, right?
uh-huh.
So at the very, very, very tip
Me
of
too.
South America, all the way to Los Angeles,
Wow.
um, on electric Harley Davidsons, which you guys
That's
worked
awesome.
on. It's a
Uh,
really good. It's a good series. But obviously, the same thing. Charging infrastructure. Tesla nailed. I mean, nailed it with that in terms of like that's what you have to have. And it was early days with Rivian too. They took prototype Rivians as like their chase vehicles there. So shameless plug, not for me, but it's a great series if you like motorcycles. The
yeah,
Harley-Davidson LiveWire, yes, the
yeah,
electric
the live
Harley
wire.
you guys worked on.
Yeah, yeah. That was an interesting one, because like that one was really challenging because that was the classic trying to fit, 10 pounds of stuff into a 5-pound bag. They really wanted a lot of power in just a little tiny spot. And so those are always the most difficult ones because you're never going to compromise on quality.
Yeah,
Um, but those are the instances where you start to push towards the fringes. So you try and make sure that you're taking all the precautions in order to make sure that there isn't anything that pushes that over the edge. So that was a fun one that we worked on. Um, but again, kind of getting back to the non-commercial vehicle side of things, like yeah, like I mentioned, the stuff that carries stuff back and forth between airplanes, people may not realize, but there's a good chance that the buses rolling throughout your city are electric buses,
yeah,
right? And so we've worked with a couple companies, Rhombus and Borg Warner, who do these huge charging. It's like a supercharger on steroids. The size of a small wall or a couch, right? And it's a charging station for a bus. And their newest product that we were working on was really interesting. And the bus would actually just roll over a pad, and that pad would be charging the battery on the bus
yes,
just
like
by it rolling over. So it would roll in and stay there as the new bus would go out and be doing it back and forth, and it would come in. This one would be fully charged and it would go out. So things like that also, that the public may not be as aware of,
yeah.
but we're heavily involved in that type of prototyping as well too. So really fun stuff to be a part of.
Yeah, and let's leave it on. I mean, you did stuff in RV. Let's
Sure.
talk a little bit about RV, and then let's end on fuel cell. We'll talk a little bit about the fuel cell stuff. So, talk to me a little bit about RV. I know some of the stuff that you guys have worked on
Mhm.
as well. Company that has done. Well, I'll just get into it. In at least in recreational vehicles,
Yeah.
there's these older parks,
Yeah.
right? When you look at RVs today, they're land yachts. Let's call
Oh
it
yeah.
as it is. They're not the RVs of old. They're not the RVs from Breaking Bad. They're
No.
the RVs. They are literal land yachts.
Yeah.
They have
Mansion on wheels.
yeah. Some of them have can you slide cars underneath it. It's
Yeah.
wild.
Yeah.
Huge pop outs, island kitchens, multiple air conditioners, 65-inch TVs. Like this is not camping. This is a
Yeah.
a
A rig.
McMansion. Yeah, it's interesting.
Very expensive too.
Very expensive. Okay,
A lot of
so you
expensive components.
yes. So you take these things, and all of a sudden, these parks that were built in the 1950s
Yeah.
that only had that the infrastructure was way back when. Uh, you start loading them that are with all these RVs at the heat of the desert, right?
Yeah.
And you have voltage sag, the infamous voltage sag, right? So as the people might not know what that when you have voltage sag, it's Ohm's law is making up for it. That AC compressor still needs to pull that amount of power in watts. So, but if it doesn't have the volts, what's it making up for? It's making up for in amps, right?
Yeah. Yep. Yep.
When amps equal heat and heat inside of motors that can go beyond a threshold, you end up burning up the whole thing.
Yeah, and it's
So
extremely common because and so to get to your point, we do a lot of business with companies who create that power conditioning, I guess
yeah,
is the best way to put it, where you have power source from the RV park, and then the mansion on wheels is right here. And instead of plugging directly into the park, there's a power conditioner that is in between those two components.
Yes.
And yeah, basically it provides a boost when that sags, and in order to make sure that you have consistent. And if all else fails, if it really starts to go overboard, then it acts as a way to trip as well.
But yeah, an
Uh,
interesting part where it just changes the relationship where like I said, it's pulling the wad, it just changes the relationship. And which is really interesting that you guys could even do that. Anyway, so there's that RV product, a little bit in RV. I don't know if there's a couple of more examples that you want to give as well.
yeah, I mean, so that's a big one, and I think about how common that is, right? Like if you're at an RV park and it's hot outside, there's a good chance that everybody is turning on their AC at the same time.
Yeah.
And so the whole park, you're having all this demand and this sap of power all at the same time. So if you don't have one of those, you're really asking for trouble.
But at the
So
same time, that goes back to
yeah,
your engineering. That's a lot of heat too. You pull that
yeah.
much, and you're trying to change the relationship between amps and volts. Uh, and then it's in the heat of the desert. That's a lot of engineering and a pretty robust transformer that needs to go into that thing too.
It is.
Same sort of thing. Probably
Yeah,
has to be over engineered to a certain degree to even handle that sort of heat.
100%. And for those reasons, that's kind of why we got tapped in order to really lead that charge into to creating a product that is able to withstand those types of demanding conditions. And so
Yeah.
that was a big one. And then through that, right, just being integrated into other RV, a lot of these companies that develop aftermarket RV products, it's multiple things, right? So that same company who maybe does like power conditioning or plug-in, they'll also do some sort of like solar that goes on top of the RV that provides additional power source, and they need an inverter or some sort of power supply coming from the solar in order to come down to the RV. And so we provide them with magnetics that assist in that power, the switching power supplies and stuff like that. So it's all the tangential products that go into that.
Yeah, if you think about an RV, I mean, like real quick, I mean, it's quite a power system because you've got onboard DC, house is AC, your alternators on DC,
Yeah.
your roof throws, higher voltage at, I mean, low current. It's like there's a lot going on
Yeah.
in just a small box. I don't think that people can really appreciate how complex and how many times things need to be transformed, no pun intended. Um, anyway, okay, let's close like fuel cell. I feel like that we can't not talk about fuel cell. I mean, that's high hydrogen and things along those lines have been kind of bubbling up here and there. You see Toyota kind of doing stuff. You kind of see it kind of bubbling, and I always am kind of fascinated with it to see if it ever really like will take off. But you guys have been involved in the hydrogen and fuel cells and stuff as well.
Yeah, yeah. So I know that we have worked on a lot of projects that have kind of broached that subject and started to get involved with it. And a lot of it, like I mentioned, comes from those relationships, not only with the companies that we're currently working with, our current customers, but then those engineers, right, who end up moving from one spot to another for their previous experience at a company, and they end up picking up and moving to some place where it's like this arms race. What's gonna take over first? Is it EV? Is it fuel cell? Is it hydrogen? Whatever it
Yeah.
might be. And so that's why we always try and keep such good relationships with all of our customers. And our customers are oftentimes not buyers. It's not the procurement team.
Mm.
It really is the engineering staff that we're working with. And so when they come to us and they say, "Hey, I'm at this new company and they have this interesting concept that has to do with fuel cells or this or that, would you guys mind taking a look?" Then that is something that's kind of how we get introduced to those types of projects. And it's exciting, to become, continue pushing that threshold, continue
Yeah.
pushing ourselves and making sure that we're able to provide that same sort of quality project or product that we did for previous projects now for that future stuff as well.
Well, I think there's no better way to wrap it up than with that statement. Justin, always a pleasure. Sometimes I'm marveled. Like, I think we could talk about this stuff. It's amazing when we just get on a roll how much you can actually talk about. Not you, but like in general, we could talk about this stuff. Anyway, always a pleasure. Appreciate the time. Looking forward to the next one. The next one is
Absolutely.
alternative energy. So shameless plug there, an actual plug for for this stuff, not another documentary. But thank you for the time. Until next time, like, comment, subscribe. We do look at the comments. I mean, if there's anything that's specific that you need answers for, we'd love to comment on there. We've gotten a few ideas from those comments itself. So comment. Any questions for Justin, we'll be happy to pass them along. So thanks,
Absolutely.
everyone. We'll see you next time.
See ya.